Hello, AP Physics 1 students. You want to have your notes in front of you as well as your problem set. And we're going to turn to problem 8, where we have built up the chart of all the different values for a converging device with a focal length of 10 centimeters. Where we're looking for patterns in terms of when things were upright or inverted, magnified, reduced, life size, real or virtual. And we're going to combine it all into one graph. So in your notes, you want to build up this graph. This will be magnification versus object distance, specifically for a converging device. And so we're going to basically summarize all the information in problem 8 on this one graph, keeping in mind, of course, it was for a converging lens, and converging mirrors do the same thing as converging lenses, so the title is for a converging device. So make sure we have a nice big graph to work with here, and we'll go right ahead and put our 0, 0 on the axes, and we'll start to label some things on the object distance axis. We can label F and 2F, because, interesting things happen at those locations. And specifically, something very interesting happens at F, so we'll just go to a dividing line there. And then we're going to start at an SO of 0 and basically go farther and farther away from the lens. So you're looking at problem 8. We'll start at the bottom of the chart where SO was really, really small. Really, we did it for 1 centimeter. We want to pretend it was right up against the lens, approaching the idea of SO being actually 0. And you can see that the image distance was really, really close to -1, negative 1.11. It was close to -1, which meant the magnification was approaching +1. And so we're basically going to add that to the scale here, so we know +1 is important, and we can go right ahead and add -1 there, and maybe the +2, -2, so we have some points of reference. And when SO was 0, it was really approaching a life-size situation where magnification was +1. So we know the graph's going to start here. It was right up against the lens. Magnification was +1. We'd also done a value of SO being 5 centimeters, which just happens to be half F. I don't have half F marked here, you certainly could mark it, but you see we got a magnification of +2, so want to think of like a data point there at half F and +2. And if it starts here and goes up like this, then you saw as it approached F, it really blew up. It became +10. So what really happens is it's some sort of curve function. I'm not going to give a name to this or talk about the actual function, but it really does blow up. It actually approaches really, really large magnifications to get closer and closer to F. Remember, what really happens is it actually approaches infinity. Remember, at F, it really is at infinity, so really just describe that as no image, and so really we can't even have anything. We just said this asymptotically approaches infinity as SO approaches F. But as soon as we get past F, then we look up to the next one on the chart there, and we had a huge negative magnification. And then as we got farther and farther from SO, the magnification in value was decreasing. So we know something like this, where it starts really here at like -infinity. So as soon as we cross over F, it drops way, way down to -infinity, a huge negative magnification, and then it's getting less and less of a magnification, less and less negative. You want to think like that. The next interesting point was 2F, where we had seen from the ray diagram and from the math that the object appears at 2F on the other side. So we have a magnification of -1. So we want to think of like a data point there at 2F and a magnification of -1. And what happened past 2F? Well, the magnification kept getting smaller and smaller in number, getting less and less negative, and so we sort of continue the curve through there. Really, the magnification is asymptotically approaching 0 as SO approaches infinity. There's other important dividing lines here. For example, we see that all of the values when we did our image descriptions were upright and virtual. So basically everything when SO was less than F was an upright or virtual image. Or really they were all ultraviolet. That's not true at all. But that the fact they're all upright and virtual, and you remember that, maybe it'll help you connect that. It's sort of not ultraviolet at all, but they're all upright and virtual. Looking for other patterns, we saw that past there, everything SO past F, everything was inverted and real, meaning everything was infrared. Again, not true at all, but if it helps you remember it, it helps you remember it. Yeah, look at the patterns. Everything we calculated there is an image description of inverted and real were larger than F. But then 2F was an important dividing line, so we're going to put a line there at 2F, and then that correlated with -1. And I'm sorry, this doesn't quite match up here. The drawing tools on PowerPoint are not as powerful as we want them to be. But we see between F and 2F, any value there, well, yes, everything was inverted and real. Everything was also magnified, right? Magnification larger than 1, larger than -1, right? Absolute value larger than 1. Once it got to 2F, it was life size, and then past 2F, all those images were reduced. And so this graph right here basically coalesces everything that was on that chart. It just collects everything we need to know about any sort of converging device, mirror or lens. That's all the information you want to know in one easy to use graph.